Hi everyone, we're going to be going over z-scores and making comparisons with z-scores. This is super helpful when we want to look at differences and make comparisons when we're looking at distributions of means. So we're just going to go over how to solve for the z-scores, convert them into percentiles using our normal distribution, and then make a judgment based off of it. So for example, say that you earned 86 out of 100 on an exam. The mean in your class was 78, and then the standard deviation in your specific class was 12.2. Now your friend earned 7.5 out of 10 on an exam for his class, and the mean in his class was 6.8, and the standard deviation in his class was 0.74. You guys want to know who did better, right? If you look at the numbers, you could assume and you can say, oh, I actually did a lot better because I got an 86, and if we were to convert his 7.5, technically he got a 75. While you can look at the numbers and make that conclusion, it's not an accurate conclusion because you want to make a decision relative to your class, and we want to help make him a decision relative to his class, right? So using z-scores and percentiles with z-scores will help us get a really good, accurate depiction of who actually performed better. So first we want to solve for each person's z-score. So the formula for z-score is z is equal to the individual or raw score, which is x, minus the mean, which is mu, divided by the standard deviation. So for your score, it's going to be z is equal to 86, right? Minus 78, which was the mean in your class, and then divided by 12.2, which was the standard deviation for your class. When you work out that math, you'll get 8 divided by 12.2, and round it up, you'll get about z is equal to 0.65 for your z-score. Same thing, we want to go ahead and find a z-score for your friend. So z is equal to x minus mu divided by standard deviation again. His individual score was 7.5. His mean was 6.8 in his class, and the standard deviation in his class was 0.74. So that would be simplified into 0.7 divided by 0.74, and you would get about a rounded z-score of 0.95. Now that we have the z-scores available to us, let's convert them to about percentages and into the percentile to get a better, accurate description. So here is our normal distribution curve and our standard normalized distribution curve that helps us bring out the percentages and helps us find a percentile to make the comparisons accurate as possible. So this orange line will relatively represent your z-score, which is about 0.65, right? So 0 falls here, 1 is here. 0.5 would technically fall in the middle, so I've just pushed it over slightly over to make 0.65. This purple line, on the other hand, will be equal to your friend's score, which is about 0.95. So 1 is here. I just moved it up just a tiny bit to be equivalent to 0.95. Now for your percentage, we want to know what your percentile lands when it's on this orange line. Anything above the 0 it will equal to 50%, right? So 2 plus 14 plus 34, this is 50%. We're not going to count this whole 34% towards your 50% because the line already cuts through before we can take that whole amount. If it was 0.5, we would have 17% here because it would be a half of 34%. But because it's a little bit more than 0.5, I'm going to add maybe 18% to the 15%, and we'll estimate that your percentile is roughly 68% when looking at this. Now your friend, if your line fell at the 1, that means their percentile would technically equal 84%, right? Because this is 50% plus 34% would be 84%. However, since your line is just a little bit above that 1, I've estimated a little bit less than that 34%, and we're going to give them about 33%. So their percentile would be estimated to about 83%. So if you're looking at your percentile, which lands at about 68% relative to your class, and your friend's percentile landed at 83% relative to your class, who performed better? Your friend performed better on the exam relative to his class grade, and his exam score on the exam. So again, we can use our z-scores, we can find them, and then we can convert them to these estimated percentiles to get a better picture of what just the numbers don't tell you when looking at them as raw data scores, rather than looking at them in these converted z-scores tell a bigger picture all the time.